Hello everyone, welcome back to my educational channel Gyan Wizard. I'm Ajmal. Today's topic is Coulomb's law in the form of a vector. In last video, we learned that when two charges are placed at some distance, a force exerts between them, which is expressed as F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Since force is a vector quantity which have both magnitude and direction, therefore we need to express the Coulomb law in the vector notation. Let's take two charges Q1 and the Q2 which are placed with reference to a point O as position vector R1 and the R2. That means R1 is the position vector of the charge Q1 with reference to point O, and R2 is the position vector of charge Q2 with this reference point. Q1 will exert a force on Q2, vice versa Q2 will also exert a force on Q1. F12 is the force acting on charge Q1 due to charge Q2. F21 is the force acting on charge Q2 due to charge Q1. Here force is expressed as, or force is the, we write in the notations, cause and its effect. R21 is the vector leading from 1 to 2 and R12 is the vector leading from 2 to 1. That means R21 is expressed as the final position minus initial position. That is R2 minus R1. R12 will be expressed as final position R1 minus the vector specifying the initial position, that is R2. R12 and the R21 both have the same magnitude, but their direction is opposite to each other. That means we can write down R21 equal to minus R12. A direction of a vector is specified by a unit vector. The unit vector is the ratio of the vector divided by its magnitude. So we can write down R21 as the vector R21 divided by its magnitude and R12 equal to vector R12 divided by its magnitude. The unit vector has the magnitude of unit. So here both vectors R21 and the R12 have same magnitude, but their direction is opposite to each other. Therefore we can write down R21 equal to minus R12. Thus we can express the Coulomb law in vector notation as the F21, force acting on charge Q2 due to charge Q1 as 1 upon 4 pi epsilon naught Q1 Q2 upon this is R21 and R21 cap means unit vector R21 which specify the direction of this vector R21. Let's see what will be the directions of the force when the charges have the same magnitude, or that means Q1 and the Q2 are both positive or both have the opposite one. That means one is positive and the other is negative one. When Q1 and Q2 both are the positive or both are negative, then a repulsive force should act on it. That means on Q1, force exerted by Q2 have the direction this one, left side, and force acting on 2 due to Q1 have directions in here, in this way. That means there is a repulsive force acts between the two. When the both charges are of opposite sign, that means one is positive and the other is negative, in that case F12 is the force acting on charge Q1 due to Q2, direction is this one, and F21 is force acting on 2 due to charge Q1, the direction is this one. That means the directions of both the charges, both the forces F12 and F21 is opposite to each other. That means a attractive force act between the two. Do we need to write down a separate formula when the both charges are the same sign? are the opposite sign. Let's see it. Let F12 equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R12, and direction is specified by R12 cap unit vector. Here we see R12 equal to minus R21. That means both the forces F12 and the F21 have the same magnitude, only their directions is different, which is in one case we will specify as the R21 unit vector, and in other case we will say R12 cap. That means F12 and F21, both the forces have the same magnitude, only their direction is different, and this direction need to be specified by the unit vector. This is all about the expression of Coulomb law in the vector notation. Hope you find this video useful. Please like this video, share with your friends, and subscribe to my channel for getting notifications on new videos. Thank you very much for watching this video.